in the last lecture, we have created a new value, hello string, and we have assigned this value to message variable. And I explained you that this value is not stored actually into the stack frame, but to the heap. In this lecture, I'll continue with this topic and I will provide you some more details. Okay, so we are calling this variable message, and I marked here the first thing I would like to fix here. I'm writing here hello, but actually what I wanted to write here was that this is our message variable, my mistake. Hello is actually stored here. Okay, so here is our message. Okay, and now I would like to distinguish what's happening when you are copying normal predictable types and when you are copying dynamic types. What I mean by copying. Okay, by copying I mean when I am creating new variable, let's say b, and I'm assigning to the b, I am assigning to the b a. Okay, this is called copying. Okay, so you can write here copying. And the copying is happening explicitly. I don't need to do anything here. I just simply get the a value and I will assign it to the b, and I'm copying this value. So that's basically I'm creating a new value on the stack. So here I had the previously a, and I just copy simply the value of the a, which was 10, to the b. So this allocated a new space into the stack, and where I am storing this value of 10. And that's basically it. When I'm creating the C, I'm writing the 15 here, and the D and 20 and so on. If I would copy, create here E, and I would assign there the result of the D, then it would copy the new value of 20, the new value of the 20 to the stack, and that would be E, and so on. Okay. Okay, but with the copying of the dynamic types is a little bit different. So what's happening? Okay, so for example, I will create here a new string or new variable, and I will call it message2, message_2, and I will copy here the message. Okay, so what's actually happening here? You can see immediately that I cannot now print line here the message. Okay, so something very very interesting happened. I cannot print line here message, but I can print line message too. I can print line message. Nothing will happen. No big deal here. But I will display now in our terminal. It's right here, cargo run. The display in my terminal will be hello. That's what we expected. We copy the hello to the message too, but actually that's not exactly how this happened. Okay. So what I'm actually copying, guys, here, you can see I'm copying the values on the stack. And what we have on the stack from the message? From the message, we have a pointer. So what I'm actually copying when I'm creating message2, I'm copying pointer. Okay, I'll actually create here some more space so they're not next to each other so we can distinguish between them. Okay, so what I'm actually copying here is this pointer here. So I'm copying the pointer, capacity, and the length. Okay, so pointer copying the capacity and the length, and this is my message2. Message_2. Okay, and pointer, of course, is pointing hello. Okay, so here we have a message. Okay, and here we have a message too. Okay, so now you can see one problem here. What actually Rust has a problem with this. Because when your function will be finished, your program will be finished, you need to deallocate a space for the message. Okay, so when the program is finished, you can imagine this is cancelled. You need to deallocate the hello from the heap memory. Of course, when the program is finished, you need to remove the things from the memory. So if you would remove now when you have a message and message2, you would remove this from the memory. So this would go away from the memory. Okay, but a message2 is still pointing to the space of the memory. The first thing, when it will be pointing here, it will be invalid, there will be nothing. And the second thing, when you will remove this space, if you try to remove this space in the memory, it's not longer, there is nothing there, that you would get here error. It's called double free error when you're trying to remove the same space in the memory twice, and that's very important error. Okay, you don't want this to happen. Okay, so this would happen if both of these, they would be existing. Okay, so what actually is happening, guys, and now it will be maybe quite complicated. It's that what it is called in Rust is that we have moved message into message2. Okay, so basically this, when we have assigned message into message2, this was moved. This was moved, and this is considered to be invalid now. This is considered to be invalid. Okay, so when your function is finished running and you want to clear the space from the memory, you are clearing only this here, message2. Okay, so you just clear this. Okay, and the message doesn't have to be clear because it's marked as an invalid. Okay, so this is just removed from the stack, but the value itself doesn't have to be cleared out because it was already moved to the message2. Okay, guys, so this is called also move. Okay, we would say it was moved. It was moved. Okay, and this is only applying. This is only applying for the things that are dynamic. This is not applying for our predictable size, for our integers and so on. This copying, this is considered to move. So you will not call it copying, but you will call it moving. So basically we have moved message to message2, and the message now, if you want to access it, will be considered to be invalid. And when you will hover over, you will see here, borrow of moved value message. Okay, you can see here also the lines. Move occurs because message has type, okay, that's actually here to here. Value moved here. So on the line 11, we have moved value. So here you can see we have moved message to message2. And on this line, already on 13, we want to try to use this moved value. Okay. So that's what's happening on the stack now, actually. Okay, guys, I hope this I hope that is now clear. So whenever we are now assigning message to the message2, we are moving value. So message will get moved to the message2, and it is considered to be invalid. So we cannot any longer to use message. All right, so now only message2 is active. We can use it normally as before. We have access to the hello. We can increase the value. We can change the hello and so on. Okay, so that's gonna be it. I don't want to explain any longer in these lectures because I will be just repeating myself. So now you can use only message2. If you would like to use print line, I will write also comment, okay? So you know, if you want to message here, cannot use message because it was moved to message2. Okay, and whenever you are doing these assignments here with the dynamic size values, you are copying only pointers. Okay, guys? Any questions to this? Feel free to ask, and let's continue in the next one. Cheers.